Hi guys, welcome. And the topic which I am going to discuss on this video is IPv4 subnetting. Let's move on to the slides. Okay, so the first basics of IPv4 addressing. So I hope you have already an idea about what is Class A, Class B, and Class C IP addresses. Yeah, because this is the classification, and this is basically comes under this is classful basically. Okay, and the range, the first octet when it is starting with 0 to 126. Okay, the ranges, it's called Class A network, and the default subnet mask for Class A is 255.0.0.0, which is equal to /8. This is a Class A network. And Class B, and it's 128 to 191. There is one address missing here, is 127, which is used for loopback purpose, so that's eliminated here. So next address is 128 to 191. Okay, this range on the first octet, if we see, we can always say this is the default Class B range, and the default subnet mask is /16. That means 8 bits, 16 bits for the network and 16 bits for the host. This is /16 in slash notation. And the next one is Class C. Class C is basically the range is from, say, it's ends here 191, so 192 to 223. Okay, 223. After that it's Class D network, and that's for the multicast address and other things, but we are not discussing on this video about that address. Okay, and okay, let's so you know what is, how to identify whether it's a Class A range, Class B, or Class C. And the default subnet mask for Class C is /24. Okay, this is a very simple thing in IPv4. And now let's move on what we should know in IPv4 address. IPv4 address consists of two parts always. Address, if you take an IP address, it has got two parts. One is called network ID, and another one is called host ID. Okay, but by seeing the IP address, we are not able to know whether it is a network ID or a host ID. So we need to have something to identify which is network and which is host. That is, we call subnet mask. Okay, we can use a subnet mask. Using a subnet mask, we can identify how many bits are used for network and how many bits are used for host. So the net mask will have a bit value of 1 for the network part and 0 for the host part. For example, if you take this subnet mask 255.255.255.0 is basically this is 255, this is the network part. That means these are all bits are 1. So if you are, and this is host bit, that means 8 bits are, so it is /24 it is called. Okay, so if you are going to know, if you have an IP address and you use this subnet mask and do ANDing with the IP address, what will happen is if you, wherever there is 1, you will get 1, but if you take this here, it is 000, right? When you AND anything with 0, if you, whatever the values you have, then automatically it will become 0. So this so the host part will get eliminated by ANDing with the subnet mask. Then you will see only one part, which is basically the number on these 3 octets, which will be representing the network address. Could be 192.168 or .10, something like this, depends on whatever. So if you are given an IP address of 192.168.10, for example, I can write it down. Example of IP address. Okay, example of IP address is 192.168.10. 11, okay, for example. So what you will do, you will write this one in the binary format and with this subnet mask, okay. 192, when you are ending with the, you will get 192, and 162 when you are ending with this 111, you will get the same value, and 10 also you will get 10. But when you are ending the 11, it will become 0. So then the one you will have the value is this one. This will be the network part. So I can highlight that will be the network part. Yeah, so that is the network address on the thing. And another thing you should know is host is, if you want to know number of host, basically if you say you have this many 8 bits, right, and 8 bits means 2 to the power of 8, that is you will get 256. 256 minus 2, you will get 254. So that will be the number of hosts on this particular network. Why? Because there are two addresses which we cannot use. One is called the network address and another one is called broadcast address. So in the range there are two address will be cannot be used. So that is why the number of hosts, basically if you want to calculate 2 to the power of number of hosts equal to 2 to the power of n minus 2. This is the way it is calculated. And if you are then another point you should know is, if you want to know the network, just you have to take how many bits are used for network part, and then the 2 to the power of n, you will get the network. So these are the some fundamentals which you should know before we proceed to the next slide. So we say that IP address consists of two, the range of addresses, class A default range, and then you say that IP address consists of two parts. One is network and host, and then using the subnet mask we can identify how many bits are used for network and host. In the subnet mask we have a bit value 1 for network and 0 for the host. By ANDing the IP address with the subnet mask, we can know the network address. So example is this one, and you can say that you have this address, and when you AND this with this subnet mask example, then you will get this 192.168, then that will be the network address, and this other part will become, and you know number of hosts if you want to calculate. So you have 8 bits for the host part. In that you can say 2 to the power of 8 minus 2, because reserved address for network. And another one is to calculate the network, you have to have 2 to the power of n, that is number of bits you have, and that will be if you have 3 bits you can have 8 networks. That's it. Okay, let's move on to the next slide. Okay, it's a reference table which I have built for making it easier for understanding, and so that we can do our subnetting quickly. So this reference table, which I am going to have it for every to solve all the questions, is basically you take binary value, say for example any octet, okay, 8 bits, right, first. So the, if you see this what is the value, that is block size for each bit has got a value, okay. The 1 2 4 8 16 32 and 64 and 128. So the bit, the rightmost bit and leftmost bit, so 128, and then the last one is 1, okay. So now in this, what you need to, what is the next line represent, because the next line represent what are the possible subnet mask in general, okay, values. So the case, if you take an 8 bit, okay, and if you have first bit, okay, this 128, that is 128. If you have 2 bits, okay, for the network on the 4th octet, then it will subnet mask will be 255.255.255.192. If you have 3 bits, okay, in case 3 bits means what will happen, you will have 2 to 4 as a subnet mask there, that is in the 4th octet. We are talking on the 4th octet, and which is also equivalent to 27, we can say, /25/26/27. And next we can say for if you are going for a 4 bits, okay, what will happen, you just 4 bits means you are going to have this one. Okay, that's basically 240. So how we built this table is very simple. 128 plus 64 192, 192 plus 32 224, 224 plus 16 240. So 240, you what is the 4 bits if you take 5 bits, if you take then 248, basically 248 will be the next subnet one. Then if you that is 248 or slash 29, you can call it slash, that is 5 bits. Sixth bit, if you take 6 bits, 1 2 3 4 5 6 bits. Okay, this is 6 bits you are going to take. 6 bits if you are taking, what is the subnet mask will be, say 1 2 3 4 5 6 bits. Subnet mask is going to be 252, and slash 30 will be the slash notation. So this is how this table is built. And similarly slash 31 and 32. Okay, because 252 plus 2 254, 250 plus 1 255. So slash 32 is basically slash 32 is 255 is the value. Okay. Okay, then next, if you are going to be in the third octet, okay, the same thing, but you are in this octet. Okay, in this octet what will happen, that's what it is represented in the third octet. Okay, third octet, it will be, if you are going to 128, if it is represented in the third octet, it means slash 17. That you should be you should understand that one. And if it is in the third octet, it will be slash 18. 192 is in the third octet, is 18, and 224 means slash, but it's all in the third octet. Okay, 20 is 240, 21 is 248, 22 is 252, 23 is 254, and 24 means you got 255. So this is how the third octet values. And again similarly you have for the second octet. Okay, second octet also, so it starts with 9 10 128 means it is slash 9 if it is in the second octet, right? And slash 10 slash 11 12 13 14 15 and 16. So that's how it goes up to 16. Okay, slash 16. Then you are coming into the third octet, and then you are coming to the fourth octet. So it's just to know what is the value if it is in each octet. Okay, 254, if you see in the second octet, okay, you are seeing 254. What does that mean in slash notation? This is what we need to find. 254 in the slash notation is slash 15. And another one more information, the block size on this octet is 2. That is what. So if you say you have slash 14 on the second octet, slash 14 on the second octet is equivalent to 252 in the decimal value, and block size will be 4. So slash 13, similarly you will have block size is 8. So the increment of this, it will increment by 8. That is what the block size it means. So if you are so whatever the value you look, how many bits here, and then the block size, we can know the block size 32, it will increment by 32, 64 or 128, whatever it is. So if you get a subnet mask of slash 128, we can always say that it's going to increment by, it is or slash 25 or 128 subnet mask, it is going to increment by 120. So first network will be 0 and the second network will be 128. If we get on the fourth octet, okay, slash 26, if we get on the fourth octet slash 26 means your subnet mask in the decimal notation, we can write it as 255 255 255.192, and it is going to increment by block size of 64. That means your network will be 2 bits, right? 2 bits you are taking, so automatically you will have 4 networks, right? 4 networks, that is 0 first network ID, and second network ID will be 64, and next network ID will be 128, then next network ID will be 128 plus 64, that is 128 plus 64 will be there, and then the last network ID will come. So if you want, we can write it down here and we can calculate. So this is how this table will be very useful when you are solving the problems in the subsequent slides. Okay, I hope you understood the table, and this is the top values represent the block size, because if you have bit 1 here, it's 128,630 block size. These are the possible masks, and then what is the slash notation corresponding to the octet if it is 128, and this is just okay. Now let's move on. I hope this table I will be using on all the questions, just for to be accurate and also to be faster. Okay, let's go to the first question. Now we will move on to the first question on this video. Okay, and what we are going to do is the router has the following IP address on Ethernet 0. Okay, this is what they say. So Ethernet 0, and okay, that's not matter, and the IP address is 172.16.2.1/23. Which of the following can be the valid host IDs on the LAN interface? So they have an IP address, okay, and which is the subnet mask is /23. So when you see the /23 subnet mask, we should know what are the possible network IDs. So /23 is coming in the octet. It is on the third octet, right? Third octet, and it is basically the block size is 2. That's what we here we go. /23 is in the third octet and block size is 2. So the IP address of the first network ID will be always 172.0/23, and the first network and broadcast ID will be this one, because the next block size is 2, that is 0 2. The network will be 2, and another network will be 4. So what will be the broadcast address? -1. That means you make 3.255, then it comes to 4. And same thing here, 2 means the next network is 2, means the previous one should be 1.255. So that will be the broadcast ID. So the host IDs will be between these two. The network ID and the broadcast ID will be the host IDs. So similarly for this second network, this will be network is this and broadcast. So between this should be the thing. So the address given is 2, okay, and it is on this range. So what we can see is 2 dot. So what are the addresses which with this 2, and in between we can check here. So these are all with 1. So this is eliminated, this is eliminated. So we have 2. So when it starts with 2.0 and it is going to 3 dot, so 2.255 is one of the valid host address, and the ending is 3.22, that's broadcast. So this is also one of the valid. So the router IP address, with this we know that the main thing is we should identify which octet. Okay, that is very important. The /23 is in the third octet, and the block size, this is very important. If you know this, then you are solved. So we can write down all the networks possible 0, and then the block size will increment by 2. That is, next network will be 2, and another network will be 4. So all this between all this, so we can say that if you go to the same question and say what are the number of hosts in this case, will it can come is 0. It is 512 host it will come, because 2 2 3 2 2 0 2 255, then 3 2 2, so 2, that will be 512 host. That's how, because the block size is 2 here. Okay, we will move on to next question, and let us be a little faster on that question. And the next question is about which two statement true for IP address. Okay, /23. There is an IP address given, and it is on /23 subnet. Okay, /23, again the same logic. It is coming on the in the third octet. Okay, that is this is the one. Okay, so we have to see /23 here, /23 third octet, and then we will write down the network IDs. So first network ID will start, block size is 2 again, so we know it will increment the block size 2. So first network ID will be 10.6/23. First network ID is 0023, and it will be the next network ID is 2, and another next network ID will be 4. So this is how the network ID will keep expanding, and this 3 is coming between this network, okay, this address. That's what we can see, and based on this we will see the subnet address is 10.16.3.0. No, it's not 2.0. The subnet address is 2.0 if they want to, but this is wrong, okay. The lowest address in the subnet is 10.16.2.1. Yes, starting address is 2.0, so that means the lowest one, the starting IP, usable IP is this one, 10.16.2.1, okay, and subnet mask. And the valid host address in the subnet is this. This is they are the valid last valid they are saying about 2.2. No, the last address could be 3. Because the broadcast address 3.255, the last address will be 3.254. So this is also wrong. So we can go here, the broadcast address this is correct, and that's right. So this is the, so if you want this one to be right, you should put 3.254. Yeah, that's wrong here, okay, cannot be 2. That's it. So with this we can find the they were given a IP address and they asked for the lowest IP address. What is the subnet address? Subnet address is also they made a wrong here, but so indirectly the question is trying to identify the subnet of this IP address. This IP address falls in this subnet, and then it is a broadcast address also. What is the broadcast address on this? Because they given the last cannot be this, it should be 3.254. So that's it. So we will go for the next question now. Okay, what is the maximum number of IP address that can be assigned to a host on a local subnet that uses, okay, they are given a subnet mask, and what is the maximum number of IP address we can go? So 2 to 4, again 2 to 4 is in the 4th octet, right? 4th octet, if you look on this table, 2 to 4 is where you are seeing, yeah, on the 4th /27, right? /27, that means, and what is the remaining bits we have, which we can use it for the host part. So how many bits are there? If you are calculating, we can say that's one way, and even we can say other method also. I can, both method we will discuss here. /27, okay, /27 means you are going to have 1 2 3 4 5 bits for the 2 to the power of 5 minus 2, that is 30 hosts. So that is the easiest way, that is also. And another method is, so we said it is on the 4th octet and it is /27, right? /27, that means the block size is 32. So we can say 32 means you will have starts with 0 32, the network part, okay, and that means between these two we will have two addresses gone, that means you will have 30 addresses. That's how it is. And divided, the 8 networks. Why we are saying 8 networks? Because 3 bits are there, right? You can go 8 networks, right? That's why this is 0 to 31 is the first network, and the broadcast address, second network 32, third network 64, 96, 128, 150, and then 192 and 223. Let me check this one, and okay, so that's how it can be done. Okay, let's go to the next question. Okay, this is about I think this question is finished, right? Yeah, /27 is finished. Okay, you have a network that needs 29 subnets. Okay, they are given how many subnet they need. While maximizing the number of host address available on each subnet, how many bits must be borrowed from the host field to provide the correct subnet? Okay, So they have said about they need 29 networks, that is a requirement. Okay, and maximize the number of host addresses available on each subnet. How many bits must be forwarded? Okay, slash 29 basically, to have 29 subnets we need how many bits? 5 bits. Okay, so if you take the 5 bits from the left, okay, that is 1 2 3 4 5, that is 5 bits. If you take basically subnet mask, and the block size is it will come 8, so 8 minus 2, 6 host and 2 to the power of 5. So we can say that how many bits we need? 5 bits are required. So if you have 5 bits you can have 32 network, right? Yeah, 32. So the requirement is 29. So we need minimum 5 bits, and we will take this 5 bits from the host part, and then we can have a network of remaining bits, that is 3 bits are there. 3 bits means you will be 8 minus 2, that is 6 host, that's all, 6 host. And we can have the subnet mask will be slash 29. Okay, that's all for on this video, and we will see in the subsequent videos more questions on subnetting. Thank you.